So let's talk about the history of foundation model. Machine learning, neural networks, deep learning are not new concepts, and these are very old concepts. As you can see in the diagram, they existed in 1980s, 1990s and 2000s, right? But there is an exponential growth after transformer in 2017, and this transformer was introduced by Google, and mostly because of the attention concept there is an exponential growth after 2017. And if you notice here, in 1950s it was rule-based data processing, that is simple processing based on rules and models. And in 1980s, machine learning. So this is data classifications. Data classification is a machine learning classification model that sorts the data into predefined groups, which we call them classes. For example, we can divide the weather into sunny or windy or rainy, etc. Right? So these are different categories or classes. And from 1990s to 2000s, it is all neural network. The objective is to imitate the human brain for labeling and training. So we have three categories: CNN, RNN and GAN networks. And in 2017, as I said, Google introduced this transformer. We already learned transformer architecture, and 2008 onwards we have GPT and BERT. We have several large language and small language models were developed, and this is mainly because of the attention concept. So as you can see, several models were built using this transformer architecture: BERT, Roberta, XLM, Albert, Electra. All these models are encoder based models. And if you see, in 2018 GPT-1 was released, and in 2019 GPT-2, and 2020 GPT-3, and in 2022 Instruct GPT, right? So all these ChatGPT models are decoder based. And if you say T5, BART, these models are both encoder and decoder. That is, it can do NAR also, and it can also generate too. So it is both encoder and decoder based model. And as you know, encoder models are designed to learn embeddings that can be used for various predictive modeling tasks. For example, you can do classification by using these encoder models, whereas decoder models are designed to generate new text, for example answering user queries, right? So example, chatbots. And if you notice here, in 2018 the GPT-1, the parameters are 0.1 billion parameters, whereas in 2020 GPT-3 the parameters are 175 billion parameters. So when they released ChatGPT, in 1 month they had 100 million subscribers, so which was the highest number of subscriptions that happened with any software releases. So you can see the exponential growth of AI. So that's about the brief history of foundation models. All right, thank you. So let's talk about what are foundation models. Foundation models are AI models trained on huge amounts of unlabeled data sets that can be used to solve multiple downstream tasks. For example, foundation models trained on text data can solve problems like question answering, that is chatbot, NER, that is named entity recognition, and information extraction. So by using foundation models, we can solve these kinds of different tasks. And also foundation models trained on images can do image captioning, object recognition, or image search, right? And these foundation models can be trained on different types of data like audio, video, 3D signals as well. So the data can be either text or images or speech or structured data or 3D signals. So we will train the foundation models with these different types of data, so we can perform different tasks like question answering, sentiment analysis, information extraction, image captioning, object recognition, and instruction following. So we can perform several tasks by using these foundation models. And a simple model can outperform if you have quality data. So this quality data is very important. So in order to build a model, we need two things. Number one, we need huge amounts of data, that is in terabytes or petabytes of data, so that the model can understand the context of the problem that we are trying to solve. And then the second one is we also need GPU, that is to process these huge amounts of data we also need GPU. So once you have huge amounts of data and GPU, you can train the model and perform different tasks. So the big companies like Microsoft, Google, Meta, etc., they have both data and they also have GPU. So they are doing the task for us, meaning they are doing the data collection, data cleaning, and building the model, training, and they trained the model and they validated the model. They've done all these tasks iteratively until the model predicts accurate results. So they are building the architecture and creating these foundation models, that is they are creating pre-trained models. So we can use these pre-trained models and fine-tune according to our business needs. That is, fine-tuning means give your company or business specific data to the foundation model that was already built, that is the pre-trained model, as an input and train the model. So we are not building anything from scratch here. We are making use of these foundation models and fine-tuning as per our business needs. In order to do that, we are learning tools and frameworks in this course. But some companies have their own models too. They build from scratch with their own domain specific data. And we already have around 10 lakh plus open source models from Hugging Face, which we will deep dive in the coming lectures. And we also have Claude, Anthropic, OpenAI, Gemini, and several other paid tools available already, right? So we can make use of those already existing pre-trained model and fine-tune the model according to our business needs so they can perform different tasks. All right, so that's all about the foundation models. Thank you. Now let's talk about applications of foundation models. So where we can use these foundation models. One potential use is when you are trying to automate different tasks or processes, especially those that require reasoning capabilities. For example, you can use in customer support or language translation. For example, if you want to translate from English to Spanish or Spanish to English or different languages, right? Or you can also use GenAI application in content generation, copywriting, image classification, or high resolution image creation, and also for editing, and document extraction or robotics, or in healthcare, autonomous vehicles, right? So these are different kind of applications where you can use this generative AI, and we will also build several GenAI applications in the coming lectures once we learn the frameworks and concepts. All right, thank you. Let's talk about different types of foundation models. There are many different types of foundation models, but the main three types are language models, computer vision models, and multimodal models. So language models means these models are designed to process and understand natural language, allowing them to perform tasks like language translation, question answering, and text generation. Examples of popular language models include BERT, GPT-3, and T5. That is, any foundation model that takes input as text and gives output as text. That is called language model. For example, let's say if you want to build a sentiment classifier. Example, let's say you have reviews which you have collected from various websites, and if your task is to classify the review, whether it is positive review or negative review, then you load the pre-trained model, for example either GPT-3 or any other model, train your model with the data that you have collected, and the model can predict the results, right? So that is about language models. And the next one is computer vision models. These models are designed to process and understand visual data, allowing them to perform tasks like image classification, object detection, and scene understanding. And popular computer vision models include ResNet, VGG, and Inception. That is, any foundation model that takes input as image and gives the output as image is called computer vision model. For example, let's say you have collected different car images and you want to design a new car. right? Then you can pass all the images that you have collected to the model as an input and get the new image as the output. And you can use different computer vision models. And the next one is multimodal models. These models are designed to process and understand both natural language and also visual data, allowing them to perform tasks like text to image synthesis, image captioning, and visual question answering, right? Examples of popular models: DALL-E 2, Flamingo, and Florence, right? So that is any foundation model that takes image as the input and text as the output, right? So different combinations. That is called multi-modal models. This is the trending model in Gen AI right now. For example, let's say a cat is sitting on a couch, right? So which is an image, and you pass that image as the input to your model. And let's say if you want to generate the description of the image, that is the text as the output. So you're passing a cat sitting on a couch image as the input to the multimodal, and you want to generate the description of the image, that is text, as the output, right? Or you can also pass video as the input, right, and then generate the text. So it all depends on your business problem. Then you can use multimodal. And we already have several models available. For example, GPT 4.0, that is multimodal, whereas GPT-4 only works with text. And GPT 3.5 also works with text, right? And Gemini 2.0 is a multimodal, right? So depending on your business needs and what kind of data you have, you need to pick the right model to solve the problem. So the foundation model is not just about LLM, right? It's a combination of LLM, computer vision, and multimodal as well, right? That is, anything that is generated can be a foundation model. So here either text or image or the combinations, right? So anything that is generated can be a foundation model. It can generate either text or video or audio or the combination, text and video together, right? Or the combinations, right? That is the multimodal. So these are three different major types of foundation models. All right. Thank you. Now let's talk about some of the examples of foundation models. So the first one was BERT. BERT was released in 2018. It is bidirectional encoder representations from transformers, and this was one of the first foundation models. And BERT is a bidirectional model that analyzes the context of a complete sequence, right? So it can analyze the complete sequence and then it will make the prediction. And it was trained on a plain text corpus and Wikipedia using 3.3 billion tokens, right? And 340 million parameters. And what are some of the applications of BERT? It can answer questions, predict sentences, and it can translate text, right? And the next one was GPT, Generative Pre-trained Transformer, and this was developed by OpenAI in 2018. And it uses 12-layer transformer decoder. Remember, all the GPT models are decoder based models with a self-attention mechanism, and it was trained on the book corpus dataset, and which holds over 11,000 free novels. And a notable feature of GPT-1 is the ability to do zero-shot learning. That means this zero-shot learning, GSL, is a machine learning classification technique, and it can classify objects from previously unseen classes as well without even receiving any specific training for those unseen classes, right? And GPT-2 was released in 2019, and OpenAI trained it using 1.5 billion parameters, whereas GPT-1 was trained on 117 million parameters and GPT-2 was trained on 1.5 billion parameters. And GPT-3 has a 96 layer neural network and 175 billion parameters and is trained using 500 billion word common crawl dataset. And the popular ChatGPT chatbot is based on GPT 3.5. And GPT-4, this is the latest version, launched in late 2022 and successfully passed the uniform bar examination with a score of 297, right? That is 76%. Okay, so that's about GPT. And the next one is Jurassic, right? This was released in 2021, Jurassic 1. It is a 76 layer autoregressive. You know, autoregressive means a decoder, that is the output of the first one will be passed again to the next one, right? So that is the decoder language model with 178 billion parameters, and Jurassic 1 generates human like text and solves complex tasks, and it can perform as equivalent to GPT-3 as well. And in March 2023, AI 21 Labs, they've released another version, Jurassic 2, which has improved instruction following and language capabilities. So that's about Jurassic 1 and 2. And the next one is Claude. So Claude 2 is Anthropic's state-of-the-art model that excels at thoughtful dialogue, content creation, complex reasoning, right? So this is one of the reasoning model, and creativity and coding. You can use it for coding as a programmer, and it is built with constitutional AI. And Claude 2 can take up to 1 lakh tokens in each prompt. That means it can take over hundreds of pages of text, that is even the entire book as well, right? And Claude 2 can also write longer documents like memos and stories on the order of a few thousand tokens compared to its previous version, right? So this is a reasoning model, and you can also use as a programmer as well because it can generate code, right? And the next foundation model is Cohere, and Cohere has two LLMs. One is generation model with similar capabilities as GPT-3, and the other one is a representation model. This is intended for understanding languages, right? While Cohere has only 52 billion parameters, but it can outperform GPT-3 in many aspects, and you can explore more. And the next foundation model is Stable Diffusion, right? It is a text to image model that can generate realistic looking high definition images, right? So many people use this Stable Diffusion to generate high quality images, and it was released in 2022 and has a diffusion model that uses noising and denoising technologies to learn how to create images. The model is smaller than competing diffusion technologies like DALL-E 2, which means it doesn't need an extensive computing infrastructure, right? Because it is a small model and it doesn't need high computing power. And Stable Diffusion will run on a normal graphics card or even a smartphone, right? So that's about Stable Diffusion. And the next foundation model is CLIP, that is contrastive language image pre-training. So in 2021, a multimodal vision and language, right? So this is a multimodal. CLIP became popular for its ability to effectively perform tasks it had not been explicitly trained to handle, right? So if you see here, this model was trained on 400 million image text pairs, right? So they have passed both image and text with the motive of learning how to connect language and images. So by using this CLIP model, you can connect language and images, and it utilized an objective of contrastive learning to learn language guided image representations, and has now found many applications in image retrieval and image text matching tasks, right? So you can see here image encoder. So this is a corgi playing a flame throwing trumpet, right? So that's about CLIP foundation model. And the next foundation model is Bloom. It is a multilingual, right? It is a multilingual model with similar architecture to GPT-3, and it was developed in 2022. If you're trying to solve the problem of multilingual, then you go for Bloom. And this model has 176 billion parameters, and they trained in 3.5 months using 384 NVIDIA A100 GPUs. And although Bloom Checkpoint requires 330 GB of storage, it will run on a standalone PC as well. If you have 16 GB RAM and you have good storage, you can use Bloom. And Bloom can create text in 46 languages, right? And can write code in 13 programming languages. So if you're trying to solve a problem that involves multiple languages, then you can go for Bloom. And the next one is Hugging Face. So this is one of the famous one. This is a platform that offers open source tools, right? So this is free, and you can build and deploy machine learning models by using Hugging Face, and it acts as a community hub, and developers can share and explore models and datasets, right? So you can also build a model and you can share it here, and datasets as well. Membership for individuals is free, that is, it is a open source. Although paid subscriptions offer higher levels of access, you have public access to nearly 2 lakh models, right? And 30,000 datasets. And we will deep dive Hugging Face in the coming lectures, right? And the next foundation models are DeepSeek and Grok. DeepSeek's aim is to achieve artificial general intelligence, right? And the company's advancements in reasoning capabilities represent significant progress in AI development. So DeepSeek is one of the reasoning model, right? And the next one is Grok. This is by Elon Musk. It is a generative artificial intelligence chatbot developed by XAI, and this is based on the large language model of the same name. It was launched in 2023 as an initiative by Elon Musk, right? So we learned different foundation models. For example, the first one was BERT, GPT, and this is Jurassic 1 and 2, and this is Claude and Cohere, Stable Diffusion, Clip, Bloom, Hugging Face, DeepSeek, and Grok, right? So these are some of the popular examples of foundation models. All right, thank you. So in this lecture, let's try to understand LLM benchmarks, that is understanding language model performance. The problem here is every week people are releasing new models, right? So how do you keep yourself up to date? So to keep yourself up to date, we have leaderboards available. So you can see the models based on different categories, like if you want to pick only the math model or coding model or in general as well. We also have some open source leaderboards available in Hugging Face, and we also can evaluate generative language models by going to this Hugging Face page. And LLM safety leaderboards, right? Let's say if you are working in a healthcare domain, right? So then safety is the highest priority. So we have models specific to safety as well. And this is LLM API link. So if you go here, you can see different API links. Now let's go to all these URLs and deep dive. So this is the leaderboard, right? So this is called the leaderboard. So you can see here based on the rank and the model name and odds, score, and when was the LLM trained, that is the knowledge cutoff date and everything, right? So if you notice here, we have different categories. So you can select the overall. Let's say if you want to use a math model, right? So select math category here, and you can see Gemini 2.5 is outperforming, right? And let's say if you want to have a coding based model, then you can select the category as coding, and you can see ChatGPT 4, that is the #1 rank, right? So similarly, if you want to select a language specific model, English, Chinese, French, German, Spanish, etc., right? So you have different language models as well. So that is how based on the category you will be able to select the models, right? So every now and then you can come to this leaderboard and see which model is performing and what is the highest rank and what is the score. So according to these parameters, you can select the best model. And here you can see multitask language understanding, right? So you can filter based on the prompt techniques as well. We will see all these techniques: few shot, fine tune, 5 shot, chain of thought, all these techniques, right? So we will learn in detail in the prompt engineering techniques section. So based on the filter also, you can pick the right model. And if you go here, I think this is kind of a similar one as we saw before. It is just displaying a different format, license, score, and what is the model name. So here also you can select different categories and select the model that you want. And now let's see the open source model, right? So this is Open LLM leaderboard. So here you have different open source free models available, and you can see Quen and different models are available. So depending on your requirement, you can select these models, right? These are the open source models, and these are the safety models, right? So if you are working on a project where safety is the highest priority, then the #1 model is Anthropic, right? Claude Anthropic. So depending on the parameters, toxicity, stereotype, ethics, privacy, right, fairness, so based on these different categories, they've prioritized these models. So if safety is your highest priority, then you can select the best model by coming here. And the next one is all the LLM API links, right? So here, this is one place where you can see different LLM API links. Let's say if you want to go to this Google Kema 3, so here you can see the API link, right? Here you have the API playground also, where you can play around with different models. Similarly, you have all other LLM models. API links are available here. Now let's see the top open source LLMs. The first one is Grok. So here I've provided the URLs also. So Grok is best used for text summarization, and next one is Llama 2. This is best used for language modeling, question answering, sentiment analysis, right, and text summarization. And BERT, it is used for text categorization, question answering, and named entity recognition, NER, and sentiment analysis. And another open source LLM is Bloom. This is used for document classification, dialogue production, and text summarization. And the other one is Falcon, right? This is best used for language modeling, question answering, sentiment analysis, and text summarization. And the other one is ExcelNet. This is best used for text creation, inquiry answering, and language modeling. And the next one is GPT, J, and NeoX, right? So this is best used for language understanding, text completion, and chatbot interactions, sentiment analysis, code generation, and content summarization tasks. And the next one is OPT 175B. This is best used for document categorization, sentiment analysis, and text summarization, right? And the XGen 7B, this is used for dialogue systems, story development, and production of creative content. So depending on your requirement, you have to choose the model. Here I have listed the top open source LLMs, right? And the next one is Vicuna. This is best used for question answering, text summarization, and language modeling. And YI34B, this is used for chatbots and interactions, with its fine-tuned capabilities extending to technical support as well, educational tutoring, and creative writing as well. And Mixtral, this is also one of the open source model, and this is best used for text generation, embeddings, and function calling, right? So these are some of the top open source large language models that we have. So depending on your need, you can choose the best model. And when it comes to selecting the right model, what are some of the parameters that you need to consider when selecting a model, right? So the first one is performance metrics or accuracy. That is, evaluate accuracy, precision, recall, F1 score. We have already seen this F1 score, and other relevant performance metrics. So when it comes to performance, the importance should be very high. Of course, the LLM should perform really well, right? And then training data, make sure it is trained really well, right? So if you have good quality data, of course the LLM will give the accurate results, right? So assess the quality, diversity, and size of the data used to train the model. So you will have to make sure what is the size of the data and how well it is trained, what is the quality data, right? So that is most important when you are picking the model. And the model size, this could be medium, either small language model or large language model. Even the small language model, sometimes it can outperform, right? So consider the number of parameters in the model which impacts the performance and resource needs, right? So model size is medium. And inference speed, right? So that is the time the LLM takes to generate the predictions. So that is the inference speed. They should be very high, right? Because when you are using LLM, you will expect the accurate results in a less span of time, right? So the inference speed is really high. And resource requirements cost, obviously the importance is high, right? So evaluate the computational resources needed, including memory and processing power. And scalability, this is also high. Determine the model's ability to handle increasing data. So now let's say down the line, if you are increasing the data, we have to make sure the model performs well, right? Or complexity without performance loss. And fine-tuning capability, this is medium importance. So assess how easily the model can be fine-tuned for specific tasks with additional data. By adding additional data, how easily we can fine-tune the existing model, right? So this is the importance is medium. And robustness, evaluate the model's ability to handle noisy or adversarial inputs without significant degradation, and the importance is medium. And ethical considerations, when it comes to ethical considerations, the importance is high, because we need to identify any potential biases and the model's impact on fairness, accountability, and transparency. So the model should give unbiased results, right? And the community and support, and the importance is medium. Consider the availability of community support, documentation, and pre-trained versions. Let's say if you run into any issues, you want to make sure you have the enough documentation and community support as well, and the importance is medium. Okay, keep these parameters in mind when you are selecting any foundation model. All right, thank you. So let's talk about ethical AI, that is responsible AI practices and the importance of addressing biases. So we have an organization called OWASP. So this is Open Worldwide Application Security Project. This is a non-profit foundation that works to improve the security of software. So before you develop any of the large language models or any of the generative AI application, right, you need to follow certain guidelines. So for example, let's say if I am sending employee information like email address or date of birth or name, etc., right, as a prompt to the model. So when you send this information to the model, all this employee information will be passed to the LLM. For example, let's say OpenAI LLM, right? Then that information will be saved on the OpenAI server, right? So you are sending your employee information to the large language model, and assume if any employee leaks any information from an organization, then that information will be leaked. So which is called sensitive information disclosure. So generally companies will ask for the complete domain specific data that you will be using for fine tuning the model, and that data will be sent to the cyber security team. Then they will use a third party tool and scan the entire data that you will be passing to an LLM. And if they identify any sensitive information, you won't be able to proceed further even with the proof of concept itself, right? When you're using a paid tool. But whereas let's say if you're using any open source model, then you can skip this step because you are storing the data in your local server and you're not sending it anywhere, right? And sometimes companies use PII reduction techniques also. They'll try to mask the PII information, that is any sensitive information they'll try to mask before they actually send it to the LLM. So the better you understand most of these 10 threats to an LLM, then the more secure the model is, right? So it is very important to take care of these LLM threats while implementing any generative AI model, either building from scratch or fine tuning an existing pre-trained model, right? So you can secure the data and you'll be able to build a reliable, safe and secure model, right? So we have a total of 10: prompt injection, insecure output handling, training data poisoning, model denial of service, supply chain vulnerabilities, sensitive information disclosure, insecure plugin design, excessive agency, over reliance, model theft. So let's deep dive all these 10 threats. The first one is prompt injection, right? So an attacker can prepare a crafted prompt and they can send it as an input to an LLM. So the LLM can execute the prompt and that can lead to data exfiltration, right? For example, let's say an attacker can employ an LLM to summarize a web page which contains an indirect prompt injection, right? And how do we prevent this from happening? To prevent this, we need to make sure that we are not giving excessive privilege to access the backend systems, right? So make sure you always provide the enough access, or try to make sure we have human in the loop, right? When we have extensible functionality, instead of completely giving access to LLM and relying completely on the model, make sure we have human in the loop when we have extensible functionality. And we also have to make sure we have established trust boundaries between LLM, external data sources and extensible system functionality, right? So we need to make sure we segregate the content that we will be accessing from the external systems, so the prompts cannot directly access the data. And few scenarios, right? For example, like I said, an attacker can inject a prompt to an LLM based chatbot as an input and make the LLM to summarize the web page which contains a indirect prompt injection, right? So that's about the prompt injection. And the next one is insecure output handling. So let's say you have a downstream application which is consuming the output that was generated by a large language model LLM without even checking what the LLM was actually generating, right? And with this, we may be able to hack and execute the remote code on the backend systems, which can lead to security concerns, right? So for example, so without cross-verifying the output that was generated by an LLM, if we use that LLM output in our application, that can execute some remote code and can cause security concerns, right? For example, JavaScript or Markdown is generated by an LLM and returned to the user, and that can result in excesses, that is cross-site scripting, right? And how do we prevent this? So make sure to apply proper input validation techniques, so when consuming the output that was generated by an LLM, instead of blindly consuming, make sure you have proper validation techniques in place, and also try to encode the output that was generated by a model so the user may not be able to interpret the undesired code, right? And some of the attacking scenarios, as I said, without proper validation of the output that was generated by an LLM, if we try to pass that as an input to our system, that may execute some of our system commands and can lead to malicious results, right? Another scenario could be if a user uses a website summarizer LLM tool that can generate the summary of an article, which includes a prompt injection, right? And another scenario could be an LLM allows the user to craft an SQL query through a chat-like feature, so it can execute the backend database and leak some of the confidential information. So it is very important to validate the output generated by an LLM before we actually consume that output in our application, right? And the next threat could be training data poisoning, meaning manipulating the model training data or model fine-tuning process so that an attacker can introduce vulnerabilities and that can compromise models security, right? And this can impact downstream software exploitation, right? Some of the examples are, so an attacker can prepare the training data document with inaccurate information and assume once the model is trained with this inaccurate training data, right, the attackers can gain the information that they are expecting from the application, right? So how do we prevent this from happening? So we want to make sure we are verifying the data sets that we will be using during the model training or training process, right? And also make sure you guardrail the training data with proper filters which can identify any malicious intent. And what are some of the attacking scenarios? If the training data is not accurate, obviously the model will predict the biased results, right? So an attacker can prepare a prompt that can inject toxic information, or your competitor can create inaccurate or false information that can target model training data, right? So we want to make sure we sanitize and have enough data filtering techniques in place in order to avoid data poisoning, right? And the next one is model denial of service. So model denial of service can happen when an attacker tries to interact with an LLM in a way that the LLM consumes exceptionally high amounts of resources, that is GPU, right? So that can lead to resource cost, right? And as a result, it can impact the performance of LLM, and it will impact whoever is using an LLM with a high amount of resources, and also it can impact other users as well, right? Whoever is using the LLM. So as an example, an attacker can prepare a query that can lead to recurring resource usage of LLM, that is by making the LLM generate a high volume of tasks in queue. Or an attacker can send queries as an input to an LLM that can consume high resources, right? Another example would be continuous input overflow. That is, an attacker can send a stream of input to the LLM which can exceed the context window. Once you exceed the context window, that means you are utilizing high amount of resources, right? So how can we prevent this problem? Like I said, try implementing input validation rules. That is, add a limit to the input that we can send to an LLM, right? Make sure we have a limit. And try enforcing API rate limits so that we can restrict the number of requests that an attacker can make. Okay, and try limiting the number of actions that can perform as a queue so we can avoid resource consumption. And few of the attack scenarios are, let's say an attacker sending multiple requests as an input to the LLM, which can lead to resource consumption, right? And another one could be an attacker can send a benign query to an LLM to see some intended text on the web page. Or another one could be an attacker overwhelming the LLM by sending a huge input which can exceed the LLM context window, right? And the next one is supply chain vulnerability. So that means supply chain vulnerabilities in LLMs can compromise model training data, machine learning models, and also deployment platforms, right? So which can cause biased results or security breaches, or maybe an attacker can bring down the entire system itself, right? So these vulnerabilities can happen when we are using some outdated software or susceptible pre-trained models or poisoned training data or insecure plugins, right? So for example, let's say if you're trying to use outdated third-party packages, right? So always make sure to use the latest version of the packages to avoid any vulnerabilities, right? And another one could be fine-tuning with a vulnerable pre-trained model. So make sure the pre-trained model that you're using is always safe to use before you use it, right? And another one could be training using poison data, right? So always make sure you have the quality data. And another example could be using a deprecated or unmaintained model, right? And how do we prevent this from happening? So try using independently audited security systems, and also try using trusted plugins, and make sure you have MLOps best practices are in place for all the models that we are using. and make sure to monitor any vulnerabilities, and also regularly review the supplier security and access. So what are the attack scenarios? So an attacker can trick developer by a compromised PyPy package, right? Or publicly available models can be poisoned, and those model can spread misinformation, right? So that's why you have to choose the right model. Or a compromised supplier employee can steal IP information also, or an LLM operator can change the terms and conditions in order to misuse the application data, right? So you always make sure you read all the documentation that is available and make sure the model is up to date, and the third party packages that we are using, they're also up to date and safe to use, right? And the next one is, this is the sixth one, sensitive information disclosure. We already talked about it. That is, LLMs can disclose sensitive information or proprietary algorithms or confidential data, which can lead to unauthorized access, intellectual property theft, and privacy breaches, right? So to avoid these risks, what we have to do, we'll have to make sure to sanitize the input data that we are sending to LLM, and also try implementing appropriate policies, and also restrict the types of data returned by the LLM, right? Few examples can be incomplete filtering of sensitive data in responses. So always make sure we have the filters in place for both input as well as the output. Whatever we are sending to the LLM as an input and what we are getting from the LLM as the output. So make sure we have the filter in place, and also overfitting or memorizing sensitive data during training. And another example can be unintended disclosure of confidential information due to errors. So how can we prevent this from happening? Like I said, use data sanitization and scrubbing techniques, and implement robust input validation and sanitization. So make sure the validation techniques are in place, and also try to limit access to the external data sources. Let's say if your application uses any external data source, make sure these models do not have those external data source access, and also apply the rule of least privilege when training models, right? So try to give as much least privilege as possible, and maintain a secure supply chain and strict access control. And some of the attack scenarios can be, an attacker can craft prompts that can be used to bypass input filters. Let's say if you add any input filter, an attacker can craft a prompt that can bypass the input filters that are in place, and reveal any sensitive information, right? And also personal data leaked into the model via training data increases risk. So always make sure the data that you are training doesn't have any sensitive information. And the seventh one is insecure plugin design, right? So the plugins can be prone to malicious requests, leading to harmful consequences like data exfiltration, remote code execution, and privilege escalation due to insufficient access controls and improper input validation. This is again, make sure as a developer you follow robust security measures to prevent exploitation, like strict parameterized inputs and secure access control guidelines, right? So few examples could be plugins accepting all parameters in a single text field, or raw SQL or programming statements, right? Another example could be trying to authenticate without any explicit authorization to a particular plugin, right? Or plugins treating all LLM content as a user created and performing actions without any additional authorization. So always make sure we have the authorization techniques in place, right? So how do we prevent this? Like I said, try enforcing strict parameterized input and perform type and range checks, and also try conducting thorough inspections and tests, including SAST, that is static application security testing, DAST means dynamic application security testing, and IAST means interactive application security testing, right? So these are the different testing techniques. So make sure they are in place, and also try having authentication in place when you are trying to access any APIs, right? And also try having manual user authorization for actions taken by sensitive plugins. And these are some of the attack scenarios. An attacker can craft a request to inject their own content with controlled domains, right? Or an attacker can exploit a plugin accepting free form input to perform data, or an attacker stages a SQL attack via a plugin accepting SQL where clauses as advanced filters. So make sure you enforce proper authorization techniques in place when you are using the plugins. And next one is, as the name suggests, it is excessive agency. So excessive agency in LLM based systems is a vulnerability caused by over functionality, excessive permissions, or too much autonomy, right? So try preventing by limiting the plugin functionality. So use it only when it is absolutely needed, right? So don't try to give excessive permissions. So an LLM agent accesses unnecessary functions from a plugin, right? So these are different examples here. And an LLM fails to filter unnecessary input restrictions, right? Or another example could be a plugin possesses unneeded permissions on other systems, or an LLM plugin accesses downstream systems with high privileged identity, right? So these could be some of the examples. And how do we prevent it? So always try to limit plugins tools that LLM agents can call, and limit functions implemented in LLM plugins or tools to the minimum necessary. So this is kind of self-explanatory, right? And avoid open-ended functions and use plugins with granular functionality. And also make sure we have human approval in place when we are trying to authorize, right? And also log and monitor the activity of LLM plugins or tools and downstream systems, and implement rate limiting to reduce the number of undesirable actions. And we already know an LLM based personal assistant app with excessive permissions which can send malicious email. So this could be prevented by limiting functionality, permissions, requiring user approval, or implementing rate limiting, right? So always make sure you do not provide excessive permissions to these LLMs. And the next one is over reliance, right? As the name suggests, over reliance on LLMs can lead to serious consequences such as misinformation, legal issues, and security vulnerabilities, right? So don't always try to rely on LLM output, right? It occurs when an LLM is trusted to make critical decisions or generate content without adequate oversight or validation, right? So when you are trying to make critical decisions, don't just rely on LLM generated output, right? So always make sure we have human in place before we consume the output that is generated by an LLM. And the last one is modal theft. So LLM modal theft involves unauthorized access to and exfiltration of LLM models, risking economic loss, reputation damage, and unauthorized access to sensitive data, right? So how can you prevent this? So always make sure you have security measures are in place in order to protect these LLM models, right? So we discussed all these 10. So make sure you keep all these 10 in mind whenever you are trying to use any large language model, right? So do not just blindly use any model, all right? Thank you.